All right, welcome ladies and gentlemen to graphing sine and cosine. All right, so some of you are probably groaning right now because the word graphing just showed up, but because sine, cosine, and all of our other trig functions are actually functions, we can actually graph them as well. All right, so I'm going to break this video into two parts. The first part being the basics, dealing with most of these key concepts here, and then part B is going to be graphing some harder examples. All right, so look for both of these coming up here. All right, so let's look at this word. This word is sinusoid. And what a sinusoid is a function that can be written in this form. And you notice that I gave A, B, C, and D all colorful or colors here just because those are really important numbers to us. They each affect the graph differently. And the goal for us in this first video is to actually figure out what those four values do physically to the graph. All right, so A, B, C, and D are all constants, and A and B cannot be zero. Neither of them can be zero. If A was zero, then we get the function where everything here is gone. It just becomes zero, and you get the function D. Well, that's just a horizontal line. We can't have B equal to zero because then we just have the sine of a number, which is just a number, and again, we just have a constant function. C and D can be zero because we're actually going to start with that, and we're actually going to start when we get to looking at the graph. We're going to look at A equal to 1, B equal to 1, C and D both 0, but we're getting up to that. Both sine and cosine, you might notice that I didn't say anything about cosine here. They're both considered sinusoids, and basically the reason is when you look at the graphs in just a minute, you'll notice that cosine can be written as just a translation of sine, like a shift left or right. All right, so let's take a look at the parent functions. We're going to look at f of x being sine of x, and we're going to look g of x equal cosine of x. And we're going to use a basic table to create values to graph, first of all, sine. So let's go ahead and I'm going to start us in red. And I'm going to put x values way over here. And here's our, let's say, our basic 5. And everything comes down to 5 in this. And if you think of our unit circle, they're very special numbers here. There's 0, there's pi halves, there's pi, there's 3 pi halves. Oops, that's kind of an ugly 3 pi halves. Let's try that again. 3 pi halves, and there is 2 pi. You might note that these are our quadrantal angles all the way around the unit circle, and you notice it goes from 0 to 2 pi, which is 1 full revolution. You might also remember that I mentioned that the period of sine is 2 pi. You'll see what that means in a few minutes. All right, so we're going to start with, let's have blue be sine of x. So we're going to let that be f of x. And we're also going to create a table for cosine as well, but let's just go ahead and take care of sine first. So if you look at your unit circle, or if you've started memorizing some things, if x is 0, sine of 0 is 0. And then the sine of pi halves is what? Y'all said 1. I know you did. I heard it. Okay, so sine of pi halves is 1. Sine of pi is 0. Sine of 3 pi halves is -1. And sine of 2 pi is 0 because it's the same thing as the sine of 0. So what does that mean graphically? So you guys are going to become very, very good, or I hope you are, at graphing trig functions. So we're going from x equals 0 all the way out to x equals 2 pi. You'll notice what I'm doing here. I'm starting at the beginning, going to the end. Then I'm cutting it in half to get pi, and I'm cutting it in half again to get pi halves. And I cut this one in half again to get 3 pi halves. So please pay attention to that little thing. It's going to come back for us when we get to graphing. It's all about going from beginning to end, cut in half, and then halves again, or the quarters. All right, so let's go ahead and plot these dots, and let's see what we kind of get here. So we get 0, 0. Oops, I forgot my up and down 1, because those are y values that show up. At pi halves, I'm at 1. At pi, I'm at 0. 3 pi halves, I'm at -1. And at 2 pi, I'm at 0. So remember what we're doing. We're graphing the parent function. All sine functions are basically going to look like this. Now the question is what's going on between these dots? Is it just a straight line up, a straight line all the way down, a straight line up? Well, it's not. And you could kind of verify for this for yourself if you put in, let's say, put in pi fourths. If you put in x equals pi fourths, you get root 2 over 2, which is actually, oh, what is root 2 over 2? 1.4 is like 0.7. So it's actually up here a little bit. So it's not halfway up. It's over halfway up. And if you go to the other side, going to 3 pi fourths, it's the same thing. It's actually up here a little bit. You continue this little pattern and you look at all your pi fourths, and you remember all the pi fourths for sine are all root 2 over 2, and root 2 over 2 being 0.75 or something like that. And you start to get this picture that it's not a straight line. It's actually a curved line. Let's see how well I can do this with this technology stuff here. Okay, so it's going to come up, it's going to curve. Oh, this is horrible. It does not bounce around like that. It's a nice, fluid curve. Ooh, that's probably my ugliest sine curve ever. All right. So this is the sine graph, or the graph of sine of x. So you got to remember, this is blue, this is sine of x here. And then we're going to look at cosine of x. So let's make cosine of x green, and we will look at g of x. We're just going to graph them on the same line here just to show that they are translations of one another. So if I go to cosine of 0 is 1. Cosine of pi halves is 0. Then we go -1. And then we go to 0. Then we go to 1. Now what does that look like? If we go to 0, 1, pi halves 0, -1, 3 pi halves, and 2 pi. Well, the same kind of thing is going to happen here. It's going to come down, and it actually will go through those pi halves dots, those intersection points that I have there. And it's going to look like this. So you notice that cosine really is just moving sine left or right, or vice versa. If you move sine to the left, you get cosine. If you move cosine to the right a little bit, you get sine. Well, here's what's the beauty of these type of functions. This pattern right here that we just graphed continues forever. So if I was to just kind of sketch up here like a basic sine curve, we know that sine starts at 0, 0, goes up, down, and up. That's kind of what our sine curve looked like. Well, this pattern continues forever in both directions. And it continues in this direction as well. Now, all the heights of these bubbles are the same, and all the depths of these valleys are the same as well. And we look at cosine. Cosine is going to do the exact same thing. It's going to come here, and it's going to go down, and let's make sure I get these things correct here so it kind of looks like I know what I'm doing. All right, and then it kind of just comes back here. Oops, missed a little bit. You get the idea. And this pattern just continues forever. Now, what I want to point out is this thing that we were talking about, the period equals 2 pi. And that's one full revolution of cosine. You go in the other direction. I mean, for sine, I mean, not the other direction. This is period equals 2 pi as well. And that's one full piece of the sine curve, and that piece just keeps getting repeated over and over and over again. So you can kind of look up here. You notice this sine curve. If I'm looking at the blue one, I go up, down, or up, middle, down, middle. There's one. Then I go up, middle, down, middle. There's 2 periods. If I go the other direction, going backwards, down, middle, up, middle, there's another period. Down, middle, up, middle, that's another period. So notice this graph has 1, 2, 3, 4, and some little bit more periods of sine, and probably about the same for cosine. I'm not going to bother counting them. So here's our parent functions. All sine curves and cosine curves look exactly like this, just we're going to end up moving them up or down a little bit, left and right, that sort of stuff, just like we do with every other type of graph. Okay, so let's move on to the letters, A, B, C, and D. All right, so we're going to look at what these 4 values do, and they're very important that you understand what each of those 4 values do specifically for sine and cosine. Later we'll get to the other 4 functions. We do the other 4 functions in the next section. Okay, so the effects of A, B, C, and D. A represents what we call the amplitude of the sinusoid. So it's how tall each wave is from the center. So if you remember our curve, I went up to 1 and down to -1. And I graphed like this. The amplitude was 1 because A was 1. If A is 2, then it would just go up to a 2 and down to a -2. If A was 7, it would go up to a 7 and down to a -7. So that's amplitude. That's the easiest one. And remember, if A is negative, it's just going to flip my whole graph over. Now, the period of the function comes from the value of b, but you have to remember for sine and cosine, the period of sine and cosine is 2 pi over b. This fraction right here is something you better memorize. Memorize that for sine, cosine. And by the way, it also works for cosecant, secant, right? So calculating the period is 2 pi over b. And it's just how long does it take for the function to repeat one cycle. So in my sine function, this was 2 pi because it took 2 pi to repeat one full cycle. So if b was 2, then it'd be 2 pi over 2, which is pi. So it actually would repeat one cycle. I would just do this. I would go, okay, well, okay, there's one period. It's pi, which means my halfway mark would be pi halves. My quarters would be pi quarters and 3 pi quarters. Now, C over B represents what we call the phase shift, and that's just left and right. Phase shift is just left and right, so it's how far the graph is shifted left or right from the parent function. And that's really not that hard when it comes down to it, because really we just look at the very first point, this point 0, 0, and we move that left or right, and then we just calculate everything from this point. It's not too bad once you get the hang of it. And remember, this is very important that you do remember that it is C over B. It's not just the C value here. It's actually a ratio of C over B. And if you think about this, this is actually the sine of B times X plus C over B. That actually shows the transformation left and right, the translation there, the X plus C over B. And then easy enough, D is actually, D and A are I think the easiest too. D just moves the function up or down. It's a vertical shift. And you'll notice in this particular function here, D was 0, so it was on the x-axis. Well, here's what I do. I say, okay, let's say I had the function of sine of x plus 7. Okay, we'll say it's the plus 7's on the outside. Here's I just go like this. Here's 7. I create this little dashed line, and that's the new center of my function. I call it my new fake x-axis. Okay, and if my amplitude's 1, then I go up to 8, and I go down to 6, and then I can just go from there. If my amplitude is 4, well, then I'm just going to go like this. I'm going to go, okay, my center is still 7, but now I need to go up 4 and down 4, right? So notice how important the numbers are on my graph. Notice I didn't change my graph at all. All I did was change my numbers. So this is why I've been stressing, and those of you that had me for the last couple years, I stress that you put numbers on your graph because I can make your graph be any function I want it to be, right? If you didn't tell me that this was 2 pi, I could say it's actually equal to 12 pi, and now you've completely messed up your graph. Okay, so make sure you're using numbers when you get to the graphing section here, and I'll keep stressing that in the next video as well. So quick examples is, I just want to find what's the period and the amplitude of this particular function. All right, so 2 sine of x. This one's pretty easy. Amplitude is 2. The period is 2 pi over 1 because b is just 1. It's the number in front of x, so it's just 2 pi. And those of you that catch on pretty quick could probably sketch this graph pretty quickly. 2, -2, and dunk, all the way out to 2 pi. And I do want you to be able to probably sketch things pretty quick like this, especially simple functions like this. Obviously make it a little nicer on graph paper, but you'll see what I mean as we get going. What about half cosine of half x? Now there's a reason I put this one in here because people mess this one up all the time. And the amplitude, again, easy. It's half. But this is the part that people mess up, the period. The period is 2 pi over half. And some people they forget their rules. 2 pi over half is actually equal to 4 pi. So notice if I wanted to just change this sketch up here, it's actually pretty easy. Now I just go up to a half and down to -1/2, and my period is 4 pi. Okay, so make sure you guys understand that 2 pi divided by a half is really 2 pi times 2. Don't forget that. Dividing by fractions. This particular one. Amplitude. Again, you should be able to know amplitude pretty easy. The amplitude here is actually 4. It's not -4. The negative just tells us we reflect over the x-axis. The period is 2 pi thirds. So that's kind of weird, and people kind of mess these ones up as well. I'm just going to 2 pi thirds. Let's think about not this, don't have this -3, this +5 here. If I was just to think my period is 2 pi thirds, well, then I have to think about halves and quarters. Half of 2 pi thirds is actually just pi thirds because you had 2 of them, so now you have 1 of them. Half of that is pi sixths, and half between here, if this is 1 pi 6, 2 pi 6, this makes 3 pi 6, which is pi halves. So notice that creates those 5 points that we're going to be using to graph. On h of x here, we could actually figure out we had a phase shift of 3/3. Most people don't really like graphing these ones, but the phase shift is 3/3, which is 1, and the minus is just like before. It's 1 to the right. And notice that we went up 5 units as well. So on j of x here, if we looked at just the phase shift is going to be pi over 4, so c over b. And since it's a minus sign, it's pi fourths to the right. So we would just start everything pi fourths to the right. And then we'd have a period of pi halves because it's 2 pi over 4. And sketching that really quickly would just be, okay, Let's move pi fourths to the right. Move that point to the right just a little bit. It is sine. Period of pi halves, which means pi halves units away, which is really 2, so it actually becomes 3 pi fourths. And then everything falls in between those 2 points. 1 full rotation. And my amplitude's just 1. So look at that. That was just a basic sketch of the sine function. Yes, I've been doing this for a long time, but once you get the hang of it, I know you guys can do this really quick. Just nice, easy sketches. Okay, phase shift to this one. Phase shift is, these actually get pretty easy once you actually start doing them. Phase shift here, just pi halves to the right. Not too bad. That actually finishes us off for the first video, just kind of looking at the basics and looking at the parent function. The second video is going to be, as I mentioned, just the graphing. So graphing examples and that sort of stuff. All right, so thanks for listening to this one. Go watch the next one so we can graph all week this week.